Okay, let's look at chapter 4, turning effects of force. Right? Now, turning effects of force talks about moment of a force, which is F, that is force, that's been calculated in newtons, and D, which is distance, or its perpendicular distance from the pivot, which is in meters. So the SI unit of the moment is the Newton meter Nm. It is a vector and thus has both magnitude and direction, and its direction is either clockwise or anti-clockwise. Right? The next, the principle of moment states that when a system is in equilibrium, the sum of its clockwise moments equals the sum of its anti-clockwise moments. Right? So equilibrium means a state where both of them have the same amount of force applied to it. Right? So let me show in a diagram what is it about. Look at this diagram. Right? Left and right. The right is considered as clockwise movement. The left is anti-clockwise movement. So if you look at the clockwise movement, there's a force of 300 N. Okay, and his distance from the pivot. This is the pivot. Okay, his distance. The person on the right distance from the pivot is 2 meters. Right? Whereas the person on the left, he has a force of 600 N, and his distance is 2 meters. Right? So calculatively, the anti-clockwise moment is actually 600 times 2, which will give you 1200 Newton meters. And the clockwise moment, which is on the right hand side, is actually 300 N times 2 N, which is 600 Nm. So if you look at this, the clockwise and anti-clockwise moment is different. Okay, there's a difference in their clockwise moments. Alright, so this shows that they are not balanced, because on the right hand side there is 600 and on the left hand side there is only 1200 Nm. So this is not a balanced moment. Alright, so this is what is meant by anti-clockwise and clockwise movement. The one on the right hand side is clockwise movement, the one on the left is anti-clockwise movement. And how to calculate is actually F times D, which is your force is 300 N and your D is 2M. Alright, so this is what's meant by moments of force. Let's go to the next one. Okay, the quantity that tells the turning effects of a force about a pivot is its moment. Number 2, the moment of a force is bigger if the force is bigger. Alright, number 3, the moment of a force is bigger if it acts further from the pivot. And number 4, the moment of a force is greatest if it acts as 90 degrees to the object it acts on. Alright, so these are the moments of force and how it forces can get bigger, okay, due to their differences of further from the pivot. Alright, so the next is calculating moment. Let's calculate the moment. Is this balanced or not balanced? Okay, if you look at the right hand side, the force applied is 1000 and the distance from the pivot is 1 meter. Whereas the person on the left is at 500 N force and the distance is 2m. So calculatively, the person on the right, he has got a moment of force as 1 times 1000 is 1000 N, and the person on the left has got an anti-clockwise moment 500 times 2000 also. So they are considered as balanced. Alright, let's look at another question. Okay, so this is also a question on calculation on moment of force. Now if you look at this diagram, the question asks which force is tending to turn the beam clockwise. So the force that's tending to beam to the clockwise is your 20 N. Calculate the moment of this force. So the moment of this force is actually 1.2 times 20 N. You can see from this diagram that beam clockwise is 20 N and its moment of force clockwise is 1.2 times 20, which will give you 24 Newton meter. Alright? And then the next question talks about which force is tending to turn the beam anti-clockwise, and calculate the moment of this force. So the anti-clockwise moment, the beam anti-clockwise is 30 N, and the moment of force anti-clockwise, which is F times D, your F is 30 N and your D is 0.8, which will give you 24 Newton meters. Alright? And then are they balanced? So how you want to find whether they are at equilibrium or not? So anti-clockwise moments must be equals to the anti-clockwise moment. So if you see just now the calculation wise, 1.2 times 20 N, you get 24 Newton meters. Anti-clockwise moment 0.8 times 30 N also gives you 24 Newton meters. So this tells you that yes, because clockwise moment is 24 Newton meters and anti-clockwise moment is also 24 Newton meters. So this is how you calculate for moment of force and seeing whether they are balanced and in a point of equilibrium.